So this one is a bag contains 3 blue discs. So you have 2 red discs and 1 yellow disc. Lee chooses 3 discs at random. Okay, from the bag without replacement. So meaning to say without replacement means you can use choose. Can choose. You cannot use binomial distribution because the number of these in the bag diminishes. Okay, so show that the probability that Lee chooses 1 blue, 1 red, 1 yellow is this probability here. So this guy here, just understand that what we need, right? If you want to use the classical method and as opposed to the choosing method, there are 2 ways. So we're going to do this. You can either 3 choose 1 times 2 choose 1 times y choose 1. Then after that, the total is 5 plus y choose 3. Okay, or you can just use basically the classical method, which is 3 over 5 plus y times a rate which is 4 plus y. It has to diminish, then y over 3 plus y times 3 y over 3 plus y. Then you must multiply by 3 factorial, because that's how you can arrange getting blue, red, y, blue, y, red, and then yellow, and so on. So basically the tree diagram. So if you're using choose, you don't need to multiply by factorial because it will already settle itself. Okay, you already settle itself. So basically you don't need to, if you're using classical method, you need to multiply by 3 factorial. This one you don't need to. So both will give you the same answer, but okay, so for example, this guy here, we know that 3 choose 1 is 3, 2 choose 1 is 2, then y choose 1 is y lah. Okay, so for the only of course we will suggest you to do the classical method for this question here because it's easier. Okay, it's easier to manipulate. Now this guy is horrendous, but it doesn't mean that you can't do it. So 3 times 2 times y, this times 2 times y, this will be 5 plus y, this is 5 plus y factorial. Then this one will be let me just do this, 3 factorial, then 5 plus y minus 3 factorial. Okay, so this one a bit messed up really, because remember how to manipulate lah. So this one NCR here is in MF27 so you just check this one. Is just NCR is n factorial, r factorial, n minus r factorial, this one. Okay, so some of you forgotten how to manipulate this guy. Okay, remember okay, this one will be 6y. Maybe I just put this as okay, the 6y is on top because it's too messy. This is y plus 2 factorial 5. Okay, we just practice manipulating our okay, there you go. So this is what you do. Remember this guy here, you will have to play. This one will be y plus 5, y plus 4, y plus 3, y plus 2 factorial. Okay, you pick the larger one of these two. So y plus 5 is the largest, so that you can cancel. So this one will be 6y times y plus 2 factorial, y plus 5, y plus 4, y plus 3, y plus 2 factorial. This one need to know how to manipulate this one. Then this is multiplied by 6. So if you were to cancel this out, it's quite okay. I think we can cancel this one and cancel this one. So we get 36. So some of you are using the choose method. This is how you do it lah. But obviously this is horrendous when it comes to like doing what do you call it, algebraically. Okay, so method 1 is not the one on the left is really not what do you call it, ideal. So you always use the when there's unknown, but you need to know how to use both, okay? Because obviously you not all the questions you can use the second method, okay? But the this is y plus 4, yeah, y plus 5. There you go. You can see that the second method is much faster. Okay, so study both of the method lah. When you use choose, you don't put factorial. So given that now at least these are replaced in the bag, so it means you put back into the bag, right? So the random S is the sum of the blue disc chosen. So S is equals to blue plus twice of the red disc chosen. Okay. Now you choose 3 this, find an expression for PS equals to 3. PS equals to 3, this guy here, remember, you have got, so the main question is always this, you want S equals to 3, okay? So we know that S equals to 3, you have 2 cases here, which is, case 1 is S equals to 3 will be S times B equals to 1 and R equals to 1. Then the other case is when B equals to 2 and R equals to 1. I think B equals to 2, R equals to 1, not an issue. This one just means probability of 2 red plus 1, 2 blue plus 1 red. Okay? This one is the one which is the probability of 1 blue and 1 red. The next question is, why do we need to fix the yellow? Bro, you are drawing 3 balls. 3Ds. In this case, it's 3Ds. You have 3Ds here. If you don't dictate this yellow can be any other color. Okay? So if you don't fix this, this guy can be red or blue. So you need to fix this color yellow, because yellow will give you a 0 it doesn't add to it. The moment this yellow ball, right, yellow this becomes red, then your S will no longer be 3. Same thing likewise, if your yellow ball becomes blue, this will never be 3 also. So that's why you need to fix this here. I think this is always the number one question which is being asked. So when you read the question, always understand you're drawing 3Ds. So understand that you have to make sure to include this. So that I think from the first part, you should know that the second method is easier. Don't use the first method. So the second method will be you one blue, one red, one yellow. This is which is 136 y. Then y plus 5, y plus 4, y plus 3. Okay, then this one will be what? 2 blue, 1 red will be 2 blue, 1 red will be 3 over y plus 5. There's 2 blue, y plus 4. Then 3, 2, then 1 red will be 2 . Then you multiply by 3 factorial over 2 factorial, because that's how you arrange the 2 blue, 1 red. Okay, my bad. So I wrote wrongly. It's 2 blue and so it's 2. Oh yes, this is 1 blue and 2.
3 blue, because 3 blue 0 red.
Oh, 3 blue 0 red. Okay, 3 blue 0 red. Okay, thank you. 3 blue 0 red. 3 blue 0 red will be 3, 2, 1. Then without this guy, 3 blue. This is 3 blue. Okay, thanks. Yeah, read wrongly. I mean, no, careless. So this is the case here. So then once you're done already, this will be 36y plus 6 over y plus 5, y plus 4, y plus 3. Factorize the y out, y plus 2. Good answer. That's it. So 3 blue, 0 red. Okay, great. And also y 0 . So you need to dictate, but this case here, if you got 3 blue, the rest will be 0 . So you don't have to worry. Okay, that's B. For part C, I'll just use what they call it. I'll just use GC all the way. I think GC can do the heavy lifting for all of the part C, because you don't, they never say without using GC . They didn't say that, right? Hopefully. So PS equals to 3 is equals to 7 over 20. So don't go and, so you can just put 6y plus 1 over y plus 5, then y plus 4, y plus 3 . Equals to 7 over 20 here. Okay. Then key in GC, you just, because y is an integer value, y is integer value, just key in GC. You get this one, 6x plus 1, then y over 4, y plus 5, y plus 4, y plus 3. Okay, then you can just go to table value lah. Then you just, okay, so this is too big. Table set is to reset it, reset to 1. Then you just go down and see which one will give you a fraction of, oh, there you go. Server 20. Number 1, y is 1. Server 20, yeah. Y is 1. Okay, just use GC. Then subsequently, right, this is where the, okay, so this question, right, you will understand that why sometimes we use this side and one time we use this side. So for, if you have unknown number of these or balls, right, you use the one on the right because it's easier. Okay, then now since you have y already, you can just use this one to calculate. So this will be 3 blue, 2 red, and y yellow. Y yellow. Oh, but you need to, oh, not so easy. So let's see. Usually what I'll do is start with 300, then 3 then 210, then 201. Then you just move on. But actually this, yeah, then after that 1 1 1 1 2 0 and 1 0 1 0 2 doesn't make sense. I think 300 210 201 111 120. Is that it? And 0 to 1. Okay, great. This will be s equals to 3 lah. This will be s equals to 2 plus 2, which is 4. This is s equals to 2. This s equals to, this will be s equals to 1 5. S equals to 4. Okay, we already gotten this right previously, so we got s equals to 3, which is this 2. We don't need to calculate this one. Do we have ps equals to, or ps equals to 3 found, right? ps equals to 3. So technically we just need to find ps equals to 4, ps equals to 2, then ps equals to 5, ps equals to 4 again. So ps equals to 5 we can calculate later. So now we need is write down what is ps equals to 4. Ps equals to 4 will just be it will be this case plus this case. So case number 1 is 3 choose 2 times 2 choose 1. Case number 2 is 2 choose 1 times 1 choose 1 over total of 6 choose 3 lah. Key in calculator. This is 2 choose 2. You got another one which is like ps equals to 2 lah. Ps equals to 5. I think is okay. Once done already, you got the probability distribution table. Ps equals to 2 will be out of the blue 3 blue choose 2 multiply by yellow choose 1, which is 1 choose 1 over 6 choose 3. For ps equals to 5 will be 3 blue choose 1 times 2 choose 2 over 6 choose 3 lah. Key in calculator. Make sure you add up all into 1 that's all. Done.